Programming your Arduino is like writing a detailed recipe for a highly obedient chef. Each line of code is a step-by-step instruction guiding the microcontroller to perform actions precisely and in the correct order. Just as a good recipe requires exact measurements and clear steps to achieve the desired dish, your code must be logically sequenced and syntactically correct to ensure your Arduino behaves as intended. A misplaced semicolon or unclear instruction can cause unexpected results, just like using salt instead of sugar. This precision is what allows simple instructions, like turning on an LED or reading a sensor, to combine into more complex, intelligent behaviors. With the right structure and logic, your Arduino can make decisions, react to its environment, and run tasks continuously with reliability. Learning to program is not just about writing code. It's about thinking clearly, breaking problems into small parts, and communicating with a machine in a way it understands. In the next lesson, we'll explore the building blocks of Arduino programming, starting with variables, data types, and simple logic. Programming is like crafting a recipe for a robot, specifically your Arduino. Each line of code acts as a precise instruction, telling the microcontroller exactly what to do and when to do it. Just as a successful recipe depends on accurate measurements and a logical order of steps, your code must be written clearly and sequentially to ensure everything runs smoothly. If a recipe calls for baking before mixing, the results won't make sense. Similarly, if your code is out of order or missing key elements, your Arduino won't behave as expected. Even tiny errors like a missing semicolon or incorrect variable can cause major issues. But with thoughtful, well-structured code, you can go far beyond basic tasks. Your Arduino can read sensor data, make decisions, and even interact with the world around it in real time. What starts as simple commands can evolve into complex, responsive systems. Mastering programming is about more than syntax. It's about logical thinking and clear communication with your hardware. It's how you turn ideas into action one line at a time. In Arduino programming, variables function like labeled boxes that temporarily store information your project needs. For example, you might use a variable called temperature to hold the latest reading from a temperature sensor. These stored values can be updated, referenced, and manipulated throughout your code, making variables essential for dynamic behavior. Equally important are data types, which act as labels that tell the Arduino what kind of information each variable holds. For instance, int stores whole numbers like 25 or 3. Float handles decimal values like 23.5. Char stores single characters like A or B. Choosing the right data type helps Arduino manage memory efficiently and interpret data accurately. For example, using a float when you only need whole numbers wastes space, while using an int to store a decimal will lead to inaccurate results. Understanding variables and data types is fundamental to writing clean, efficient code. It ensures your Arduino can process information correctly and respond to changing conditions in real time. Control structures are the decision makers and timekeepers of your Arduino code. They allow your program to respond intelligently to inputs and perform actions repeatedly when needed, just like a traffic system guiding vehicles based on conditions. The if-else statement acts as a conditional detour. It checks whether a specific condition is true and guides your Arduino to take one path or another based on the result. For example, if the temperature is above 30 degrees Celsius, turn on the fan. Else, keep it off. For loops are used when you want to repeat a task a specific number of times, perfect for blinking an LED 10 times or scanning multiple sensor values in sequence. While loops, on the other hand, keep repeating an action as long as a condition remains true. This is useful when you want your Arduino to keep checking a sensor until a certain threshold is reached or a button is pressed. These control structures give your project dynamic behavior, making decisions, adapting to changes, and repeating tasks without manually writing the same code over and over. In Arduino programming, comments act like signposts or sticky notes in your code. They don't affect how the program runs. Arduino simply ignores them, but they are incredibly valuable for humans. Comments explain what each part of the code does, making it easier to understand, especially when returning to a project after some time or when sharing your code with others. A simple archives turn on LED if button is pressed, can save you and others hours of confusion later. Equally important is your code structure. Using consistent indentation and spacing helps visually organize your program. It separates logic blocks and shows what belongs inside loops or conditionals. This makes your code easier to read, debug, and expand. Think of your code like a well-organized book. Chapters, functions, paragraphs, code blocks, and punctuation, indentation all make it easier to follow the story. Clean structure isn't just about style. It's crucial for collaboration, maintenance, and avoiding hard-to-find bugs.